Find the equation of a line perpendicular to the line joining the points -3, 2 and 9, 1 and passing through 0, -3. Now, to find the equation of a line, we need to use any one of the following three forms. The slope-intercept, the slope point form, and the point form. Now, when a perpendicular line is given, it is an indirect way of giving a slope. So this perpendicular line indirectly gives a slope. So the R line is perpendicular to the line joining these 2 points, and it also passes through this point. So the equation of a line will be found using slope and point. So therefore we have to use slope and point form. Because see, a perpendicular line is given and a perpendicular line indirectly gives a slope and a point is given. So a slope point form has to be used. Now, but there is a slight problem. See, the line which we want is perpendicular to a line joining -3, 2 and 9, 1. This is the line we want. It is perpendicular to line joining -3, 2 and 9, 1, and the speciality about a line is it passes through 0, -3. But there is a problem. There is a slight problem. The problem is, in order to find the slope which is given by the perpendicular line, we need to know the equation of this line. Because once we know the equation of this line, it is very easy to get the slope. We know, suppose if this perpendicular line was given as, say, something like 5x plus 3y equals 2, we know how to find slope. Just take this that side, divide this by number in front of x will be your slope. All this we know. But the problem is, now this line that is there, its equation is not known. That is the problem. So our first aim should be to find the equation of the perpendicular line. Basically, our first step is has to be to find the equation of this line, the line that will pass through these 2 points. Because once we know the equation of this line, we can find its slope, and using the slope and this point, we can find the equation of the line that we want, basically this line. Fine. So our aim at first has to be to get the equation of this green line. Now, the speciality about this green line is it passes to the point -3, 2, and it also passes to the point 9, 1. So the green line passes to, this is its point 1, and it passes to point 2. Now, when a line passes to 2 points, its equation can be found using the point form. So the equation of this green line can be found using this point form. Okay, so we first find the equation of this green line. The green line equation is two-point form. Using two-point form is y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. Now we have 2 points -3, 2, 9, 1. Take this point as x1, take this point as y1, this point as x2, this point as y2. Just substitute in this y minus 1 upon x minus -3. Y2 is 1. See, y2 is 1. You see, y2 is 1. So I've just used y1 is 2. So y1 is 2 upon x1 is 3. So this is minus 3, that is correctly used. Y2 is correctly used. Y1 is minus 2. X2 is 9. X1 is minus 3. So what we get is, after working, we get y minus 2 upon x plus 3 is equal to, what is 1 minus 2? It is minus 1. This is 9 plus 3. This is minus 1 upon 12. So we are left with y minus 2 upon x plus 3 is equal to minus 1 upon 12. So what we have basically done is, we have found the equation of this line. The equation of this line is known. Now our next aim is to find the slope of this line. But the problem with this is, in order to find the slope, we need to have the equation in a form in which we can find the slope. Basically, we need to have this equation in the following form. Something like ax plus by equal to c, as discussed in the previous video. Now to bring this equation in this form, we cross multiply. Take this 12 this side, x minus 3 this side. So we get 5 minus 2 into 12 is equal to minus 1 into x plus 3. So we do this 12 to both, and this minus 1 also to both. So we get 12y minus 24 is equal to minus x minus 3. This minus came inside and met both. Now all x and y's together and numbers other side. So 12y plus x is equal to minus 3 plus 24. Basically what has happened here is, this x came this side and this 24 went the other side. So we are left with x plus 12y is equal to 21. 24 minus 3 is 21. Now we can get the slope of this equation. Now we can get slope how? Just take this x that side and give this 12 also to the denominator, then it will share to both, and now we can say that the slope of this line is, slope of the perpendicular line is minus 1 upon 12. Now what we have basically done till now is, we have found the equation of this perpendicular line, and from equation we have got the slope of the perpendicular line. Okay, now our aim has to be, as expected, to find the slope of required line. This is our required line, so our aim has to be to find the slope of this required line, which is marked in yellow. Now it's very easy to find the slope of required line. We all know slope of required line is equal to minus 1 upon slope of perpendicular line. Minus 1 upon slope of perpendicular line. Perpendicular line. Now slope of perpendicular line is minus 1 upon 12. So when there is a number on top and a fraction below, what happens is, the number survives, the fraction becomes ulta. So you cancel, and you get the slope as 12. So now what is happened is, we have the slope, we know the slope of this line, yellow line, and we know the point through which it passes. So now we have to use simply the slope point form to get the equation of this required line. So the equation of a required line is, using the slope point form, y minus y1 upon x minus x1 is equal to m. So we use y minus 3 x minus 0 is equal to m. So y plus 3 upon x is equal to 12. That's it. That's the equation. Okay. Now I want to comment on this, on one short trick. The short trick is, so once you have, see, suppose you have converted your, this short trick you can only follow if you are very confident. See, once you have got your equation of the perpendicular line in this form, once you have got the equation of your perpendicular line in this form, the number that appears here is actually your slope of perpendicular line. This number that appears here is actually the slope of perpendicular line, because after, even after working all these things, what we get the slope of the line as minus 1 upon 12. So if you want to use the short trick, you can directly use the number that appears here is the slope of perpendicular line, and from there you can actually avoid all these steps if you know this short trick. Okay, now there is one more problem that you have to try for practice, that is, find equation of line passing through passing through minus 1 minus 2 and parallel to line joining 0, 2 and 5, 1. Okay, so basically in our case what is happening is we have to find the equation of a line which passes through a point, this is a point, and parallel. Now parallel is nothing but slope. So basically we have to use something called slope point form. But there is a slight problem. The problem is we have a line which passes through, a line passes through minus 1 minus 2. It is parallel to another line. This line, red line, passes to 0, 2 and it passes to 5, 1. Basically, our idea is what? To use slope point form. Now, to find the slope, we need to first have the equation of parallel line. We need to first have the equation of parallel line. Once we have the equation of the parallel line, say suppose the equation of the parallel line is, after finding we get it as 7x plus 3y plus 12. It is very easy to get the slope of parallel line. And from there, it is also very easy to get the slope of required line. So our first aim is to find the equation of this red line, which is the parallel line. Now, if you observe, the red line passes to 2 points. So when a line passes to 2 points, we find its equation using the point, which is also called a 2-point form. 2-point form. So we will now find the equation of parallel line. The equation of parallel line is equation of parallel line is y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. So you call this as x1, call this as y1, call this as x2, call this as y2, because these are the 2 points to which the line passes. So this will be x1, y1, x2, y2. Now just substitute y minus 2 upon x minus 0. What is y2? 1 minus 2 upon 5 minus 0. So you're left with what? You're left with 5 minus 2 upon x is equal to minus 1 upon 5. Now, in order to get the slope, we need to first convert this line into something like ax plus by equals c. Now to do this, as expected, we do a technique called cross multiplication. So we do a technique called cross multiplication. So we do 5 into 5 minus 2 is equal to minus x. So 5, when it comes inside, it gets 5 minus 10 is equal to minus x. So you get what? 5 plus x is equal to 10. So you get x plus 5 equals 10. So now this is the equation of parallel line. Basically, to observe properly on the graph, we have now got the equation of this line. This line equation is obtained. Our aim is to now use this line and find its slope. Now to find the slope of this line is pretty easy because now it is in the form that we want. So we keep 5 by this side and take x on the other side. We also throw this 5 on the other side. It gets shared by both, and this number which is in front of x, which is actually minus 1 upon 5, is the slope of parallel line. So the slope of parallel line is minus 1 upon 5. Again, if you observe, this slope is actually the number that is appearing here. So the slope, you can actually skip all this step and directly say that the slope of parallel line is the number that is appearing here. You can do that. Right? Now, once the slope of parallel line is obtained, we find the slope of the required line as it is equal to the slope of parallel line. So it is equal to slope of parallel line, and this is equal to minus 1 upon 5. So now the required line that we have, that is this, which I'll mark now in yellow color. This is the required line. We know the slope of this required line now, and we also know the point through which it passes. So using slope point form, we find the equation. So the equation of required line is equation of required line is using slope point form 5 minus y1 upon x minus x1 is equal to m. Now, if you observe properly in the question, the point that it passes through was given as minus 1, minus 2. So instead of this x1 and y1, we are going to use minus 1, minus 2. So instead of the point is minus 1, minus 2, so x1 is this, y1 is this, and our m is minus 1 upon 5. So y minus minus 2, x minus minus 1 upon minus 1 upon 5. This will turn out to y minus minus will make it plus, x plus 1 is equal to minus 1 upon 5. This is it.